The stars closest to Earth are nothing like the stars most of us picture when we think about the night sky. Our nearest neighbor is so faint that you cannot see it with the naked eye, yet it is active enough to blast its closest known planet with powerful bursts of radiation. One of the brightest stars above us has the remains of another star orbiting beside it, and one of the closest systems to the Sun went completely unrecognized until 2013. Put those facts together, and something much stranger appears. Statistically, these stars may actually be more normal than our own Sun. For most of us, the night sky creates a pretty convincing picture of what a star is supposed to be. They look bright, steady, and distant, almost like tiny versions of the Sun, scattered across the darkness. Once you learn that the Sun itself is a star, it is easy to assume that other systems follow roughly the same pattern. One stable star, maybe a few planets, and a lot of empty space around them. But what we see at night is heavily biased toward the brightest stars. Small, cool stars can sit surprisingly close to us and still be far too faint to notice without a telescope. So when you look up, you are not really seeing a map of our nearest stellar neighbors. You are seeing the ones bright enough for human eyes to catch, and the closest star of all is where that familiar picture starts to come apart. Proxima Centauri sits only about 4.25 light-years from the Sun. It is a small red dwarf, and orbiting it is Proxima B, the closest known exoplanet to Earth. The planet has roughly the mass of Earth and is probably rocky. It completes an orbit in only about 11 days, but because Proxima is much cooler and dimmer than the Sun, Proxima B still lies within the star's habitable zone, the region where liquid water could potentially exist if conditions are right. At first, that sounds almost ideal. It is close, probably rocky, and in the habitable zone. Then you look at the star itself. Proxima Centauri is an active flare star. It can produce powerful bursts of ultraviolet and other high-energy radiation, and models suggest that an Earth-like atmosphere placed in Proxima B's environment could struggle to survive over very long periods. We still do not know whether Proxima B has an atmosphere at all, and that uncertainty matters. The nearest potentially temperate planet we know of is not orbiting a calm second sun. It is circling something far more active. At that point, it would be easy to treat Proxima as the oddball of the neighborhood, but it really isn't. If you could take 100 stars from the Milky Way and line them up in front of you, roughly 73 would be red dwarfs. Only a small fraction would look anything like the Sun, and suddenly, Proxima does not seem quite so unusual. The typical star in our galaxy is smaller, cooler, and dimmer than the Sun. Many would be completely invisible to the naked eye, even if they were relatively nearby. Stars like Proxima dominate the galaxy. You might think the planets around such common stars would at least be easy to make sense of. Barnard's star says otherwise. It sits about 6 light-years away and has frustrated astronomers for more than a century. Over the years, several apparent planet discoveries came and went. Signals looked convincing, only to weaken or disappear. When better observations showed that stellar activity or measurement effects could explain what astronomers were seeing. The breakthrough came in 2024. Astronomers confirmed a tiny planet whipping around Barnard's star every 3.2 days. By March 2025, independent observations had confirmed 4 planets with masses below that of Earth, all packed into extremely tight orbits. None lies in the habitable zone. After decades of planets appearing and disappearing, Barnard's star finally gave astronomers 4 worlds they could be much more confident about. And none looks remotely like a second Earth. But mistaken planets are not the strangest things sitting nearby. For that, you only have to look at Sirius. Sirius is the brightest star in the night sky. It is easy to find, easy to recognize, and has been familiar to humans for thousands of years. But orbiting beside Sirius A is Sirius B, a white dwarf, the collapsed remnant of a star that reached the end of its normal life long ago. The numbers for Sirius B almost stop making intuitive sense. It contains nearly as much mass as our Sun, squeezed into an object smaller than Earth. Almost an entire Sun compressed into something roughly planetary in size, and it has been circling beside one of the most familiar stars in the sky all along. The brightest stellar system most of us will ever see contains the remains of a dead star, and even that is not the strangest thing we managed to overlook. Only about 6.5 light-years away lies Luhman 16. It is a pair of brown dwarfs, objects that never became massive enough to sustain the normal hydrogen fusion that powers stars like the Sun. They are incredibly faint, but 6.5 light-years is almost nothing on a galactic scale. And yet astronomers did not identify the system until 2013. One of the nearest systems to the Sun had been there throughout all of recorded human history. We simply had not realized what we were looking at. You could argue that we are picking the strangest neighbors, and that is partly true. The galaxy contains a huge range of stellar types, ages, and histories. No single object represents every star, but one fact is hard to get around. Red dwarfs dominate the Milky Way. Stars like the Sun don't, so perhaps the universe is not failing to resemble the solar system. Perhaps we have simply been using the solar system as our definition of normal. Kevin Luhman later found a simple way to show just how close the system he discovered really is. While studying infrared observations from NASA's WISE telescope, he recognized that the faint objects in the data belonged to an extremely nearby system. He pointed out that television signals transmitted from Earth only a few years earlier would already have crossed the distance to Luhman 16. That makes the discovery feel very different. This was not some hidden object on the far side of the galaxy. It had been sitting in our own stellar neighborhood the entire time. Nothing suddenly appeared. We had simply learned how to recognize it. Human eyes detect only a narrow slice of the electromagnetic spectrum. Change the wavelength, build a different detector, put that detector above Earth's atmosphere, and objects that were effectively invisible for thousands of years begin to emerge. Astronomy has a long history of discoveries like this. Every time we build a new kind of eye, the universe seems to change. But the universe hadn't changed, only what we were capable of seeing had. So maybe the better question isn't why our nearest stars look strange. It is how much of that strangeness is actually normal. How many rocky planets around the galaxy's enormous population of red dwarfs can keep their atmospheres for billions of years? How many faint nearby objects have we still not fully understood? And as the next generation of telescopes studies nearby worlds in greater detail, will the solar system start to look more ordinary, or even less so? The next big surprise may not be waiting somewhere across the Milky Way. It may be almost next door. We look at Proxima, white dwarfs, brown dwarfs, and violent red stars, and wonder why so much of our stellar neighborhood feels unusual. But unusual compared with what? We learned what a star was from the one star close enough to turn our sky blue. We made it the reference point. Then we looked outward and expected nature to repeat the pattern. It didn't. Maybe nothing about our nearest stars seems normal because we learned the meaning of normal from the sun. And maybe all this time, we were looking at the strange one.